Let's see the next topic, file system structure. File systems are maintained on secondary storage disk. Okay, so these file systems provide an efficient and convenient access to the disk by allowing the data to be stored, located, and retrieved easily. The reasons for storing these particular file systems on disk are: one, it is a disk can be rewritten on in a place. That means once a memory block is used, we can reuse that particular memory block. Okay, that means it is possible to read a block from the disk and make some changes into it and store it on the same place, that is right back to the same place. So this is possible with the disk. Okay, then the disk can access directly any block of information it contains. That means we can access the data by using sequentially. We can access the data sequentially and directly, but that is randomly. We can access the data randomly. Okay, so the read switching from one file to other file is easy, because the moving of disk head from one place to other place, it is simply rotating the head disk and placing that particular pointer to that particular block. Okay, so IO transfers between memory and disk are performed in units of blocks. Okay, here the memory, we will divide it into different blocks of data. We'll divide it into blocks of data. Okay, so if you want to transfer the data, a block by block transfer will be done. Okay, a block may be one or more bytes of data. Okay, so here each block has one or more sectors. Each block has one or more sector. The sector size varies from 32 bytes to 4096 bytes. That is, it is 32 bytes to 4 KB. Block size will be 32 bytes to 4 KB. But most of the times, the usual byte size are the default byte. Usually, the byte size is equal to 512 bytes. That is, on an average, it will be your block size equal to 512 bytes. Okay, and next see the design issues of file system. Design issues of file system. Here we have two design issues. First one, defining how the file system should look to the user. Okay, so this defines a file and its attributes. Okay, so this task involves defining a file and its attributes and the operations allowed, what are the different operations allowed on a file. Okay, and the directory structure for organizing the file. We have seen several directory structures, and which directory structure we need to use to organize those files in the system. Okay, so this is one design problem or design issue that is related to file system. The next design issue is creating an algorithms and data structures to map logical file system to physical secondary memory storage device. Okay, that means this particular logical file systems, we need to write an algorithms and we need to create some data structure, some data variables, so that it can be mapped easily to secondary storage. That is, it can be mapped to your hard disk or solid state disk. These are the two issues that comes with file systems. Okay, so let's see the layered structure of this particular file system. In the layered structure, you can see the uppermost layer will be your application programs, that your software that you are using, and bottom layer will be device. Okay, so application program accesses the IO device, accesses IO device. In between your application program and IO devices, there will be logical file system, file organization module, basic file system, and IO control. Okay, so in order to run any device, that means in order to perform any task on a device, that is IO, input task or output task, we can simply say that read operation or write operation, read operation or write operation on a device. The operating system will send some particular commands to the device that will be taken. Okay, that will be interpreted perfectly and the corresponding operation will be done. So this IO control layer, okay, consisting of device drivers and interrupt handlers, device drivers and interrupt handlers. Okay, so these IO control layer is responsible for transfer the information between your main memory and your disk, main memory and disk, because we don't store the entire process onto main memory. Only few portion of the memory, a few portion of the process will be stored onto main memory, and remaining memory will be stored on disk. Whenever the CPU wants that particular remaining memory of the data, the CPU, now the data has to be loaded into main memory. Okay, so this will require one IO operation. This will require one IO operation on the disk. Okay, so these commands will be understood by device drivers. Okay, device drivers, and we need some interrupt. The system has to use some interrupt. So what are those interrupts and how those will be handled, that will be taken care by IO control level. Okay, then next level will be basic file system. This is very easy. It issues generic commands to appropriate device drivers. So where's device drivers are present? Here, device drivers. Specific commands to device drivers to read and write physical blocks of data. So where these physical blocks? These physical blocks are belongs to disk, to read or write physical blocks of data on the disk. Okay, so each physical block is identified by a numeric disk address, identified by numeric disk address. Okay, so which drive it belongs to and which cylinder it belongs to, what is the track number, what is the sector number. Okay, this constitutes the address of a block. This constitutes the address of a block. Okay, so it manages the memory buffers and cache, manages the memory buffers and cache that holds various file systems, directory and data blocks. So basic file system manages memory buffers and cache, memory buffers and cache to hold various file systems, directory and data blocks. Okay, so above this particular basic file system there is a file organization module. Okay, so the file organization module knows about the files and their logical blocks and physical blocks, knows about the logical blocks and physical blocks. Okay, so it includes the free space manager. That what is mean by free space manager? This free space manager maintains the information regarding what are the blocks that are already allocated and what are the blocks that are free. Okay, so if you want to store any data to the disk, this particular process is while executing this one process, if the process is adding extra information onto the disk. Okay, so this particular data, new data, will be stored on the free blocks. Okay, so the system will contact free space manager and it will give you the list of free blocks, okay, which is not allocated to any process or any program. Then that new data will be added to this particular free blocks. Okay, so the file organization module includes the free space manager. Okay, so let's the upper above this particular file organization module there is a logical file system. Okay, logical file system. Here it maintains metadata of information. It maintains metadata of information. That means the file metadata, the file metadata. What is meant by metadata? The It shows all the properties. It will store all the properties of a file except the contents, actual contents it stores. That means it maintains, okay, it manages the file names, file id, file type and file protection bits and file location. Every details are present in this particular uh, maintained by logical file system. So it maintains file structure using file control blocks, FCB. Okay, by using a block called file control block. Each file will have its own file control block. That particular file control block will have all its properties, that all the properties are stored. Okay, the file control block have the information about the file and its ownerships, permissions and location. Okay, so in Unix we'll call this FCB as inode. FCB as inode. Okay, so logical file system is also responsible for protection, whether to write, read on a file or write on a file or execute a file. There are some read only files will be. Okay, so it will be belongs to this particular protection property. Okay, advantage of layered architecture, it minimizes the duplication of code. It minimizes the duplication of code and code can be reusable. Code can be reusable. But the problem with layered architecture is it will give more overhead on the operating system, because once you go to one layer after other layer, okay, one layer after other layer, you need to use several system calls. You need to use several system calls that includes different parameters are added while you move from one layer to other layer. This will leads to a extra system overhead. Then let's see different file systems supported by different operating systems. First one, in Unix, we'll use Unix file systems. Okay, it is based on Berkeley Fast File System, FFS, Fast File System. Then most widely used operating system is Windows, where we'll use FAT32, NTFS. FAT means file allocation table. Okay, we'll use file allocation table, that is FAT. And when it comes to NTFS, the new technology file system, it is called new technology file system. Okay, so the current Windows is using NTFS format. Current Windows is using NTFS format. The standard Linux uses extended file system, EFS. Extended file system, EFS. The versions are ext3 and ext4. Okay,